Okay, so we are going to be using pi r squared minus r squared dx from -2 to 1. My outer radius is going to be the equation that is farthest from the axis I'm going around. So this distance right here, top minus bottom, that outer radius is -x plus 3. Now I'm going to use my inner radius. And my inner radius, I will do in purple if we can see it, is this distance, the equation that is closest to our axis. That distance right here is this bottom equation, which is x squared plus 1. Ooh, that's not visible at all. So x squared plus 1. So I am going to plug in both of those equations. I'm going to be very careful to distribute that negative, and then I'm going to integrate. Okay, I'm going to have to erase this so that you can see the pretty pictures. Here it is. And I'm going to make these smaller and smaller and smaller. This looks like a lampshade to me. Okay, and we went through all this already. Make sure your parentheses are right. And again, I don't know why I put the pi there. I usually keep that on the outside when I actually do the problems. And for this one, 117 pi over 5. Okay, here we go. And already I'm saying, uh-oh, because we're going around something that's like the y-axis. So I'm going to sketch these first. Y equals x squared. Y equals x squared. And then I'm going to, let's see, here's y equals 2x. So you look for the region that is bounded by those two things. So this one is y equals 2x. So this region right here is what we're revolving. Now it says we're revolving around the line x equals 2. Okay, I need to find some stuff here. Okay, so this point I know is 0, 0. And now I'm going to set these two equations equal to each other. Make sure you show your work for these. And so this other point up here is 2, 4. Okay, for the sake of space, I'm getting rid of this. Okay, now I'm going around the line x equals 2, which conveniently is right here. Me trying to mirror it. Poorly, pretend. And again, I have to draw a perpendicular line. Mirror it over here, give it some thickness. Okay, so there is our washer, with this being the center. That's what we're cutting out of this thing. And I'm going around a line that is like the y-axis. So everything has to be in terms of y. So instead of y equals x squared, I have to use x is the square root of y. Instead of at y equals 2x, I'm going to use x equals y over 2. I'm still going to use pi r squared minus r squared, but this time I have dy. And I'm not going from 0 to 2 because that's along the x-axis. I'm going from 0 to 4 along the y-axis. So this is 0, this is 4. Now we have to find the outer and the inner radius. Okay, this is the hardest part for some kids. I need this distance right here. This is my outer radius. You should draw that in there so you can see it. If that is my outer radius, I need that distance, which means I have to use right minus left. So 2 minus that line is y over 2. And now I need to find my inner radius. That's this distance right here. Let's use orange. This distance right here. And again, I'm using right minus left, so that's going to be 2 minus the square root of y. I will plug both of those things in, square both of them, and then integrate. That is also another mistake. The number, I think it's the number 3 biggest mistake on the AP test is kids will do r minus r and square it. You have to square them individually. You're doing the disk method twice. And that's it for discs and washers. This is the end of the first section.